Section 6.2, one-to-one functions, inverse functions. All right, the main idea in this section is that of an inverse function, but in order to understand inverse functions, we first have to study the concept of a one-to-one function. So that's where we're going to start, okay? So go ahead and look under where it says determine whether a function is one-to-one. Okay, so let's talk about what this phrase one-to-one means. It says a function is one-to-one if and only if every y value corresponds to only one x value. Okay, read it again. A function is one-to-one if and only if every y value corresponds to only one x value. Okay, there's a couple of things that you really need to concentrate on in that statement. First of all, we're going to be dealing with functions automatically. Okay, you're going to have a function and you're just trying to figure out whether it's one-to-one or not. Okay, so since we're dealing with a function, that means every input will have a single output. Okay, so then you have to check another requirement to see if it's one-to-one. And the one-to-one requirement is that every y value corresponds to only one x value. Okay, so how you should interpret that, okay, is that there's no sharing between x's and y's. Okay, so like each xy pair, the x and the y, they're married to each other. Okay, they're not shared among, other xy pairs. Okay, if you have a y value, for example, the y value can only belong to one x value. Okay, you can't have a y value that's the y value for more than one x value. Okay, a way to kind of think about it visually, this whole idea of one-to-one, is to think about your hands. Okay, so if you have your left hand, okay, I cannot draw here. Here's your left hand, and then here's your right hand. Okay, so we have 5 fingers on each hand. Okay, we can build something called a one-to-one correspondence between our fingers. Okay, so like we match up the thumbs. Okay, I know that's, drawing it, I'm not matching up the thumbs, but you get what I'm saying. You're going to match up the thumbs. You're going to match up the index fingers. You're going to match up the middle fingers. You're going to match up the ring fingers, and you're going to match up the pinkies. Okay, so basically there's no sharing among the pairs. Okay, each pair is uniquely paired up. Okay, so that's how you need to think about it. Okay, and I'll even write right here, no sharing. Okay, all right, so let's take a look at example 1. Okay, what we have here is a set of ordered pairs in each part. Part A and part B each part has a set of ordered pairs, and the directions say to determine whether the function is one-to-one. Okay, so if you think back to the beginning of the semester, we saw something like this where we had this set of ordered pairs. The directions back then were determine whether or not this represents a function. Okay, so now we're told that what we've been given does represent a function, which you can confirm through drawing an arrow diagram. Okay, but we're going a step further. We're trying to figure out if this set of ordered pairs represents a one-to-one function. Okay, so it's a really good idea to draw an arrow diagram like we did back in the day for functions to tell if it was a function. Okay, it's very visual. You'll be able to see, or you'll be able to confirm that it is a function, and you'll be able to tell whether it's one-to-one or not. Okay, just from the visual. Okay, all right, so let's look at part A. Our ordered pairs are 2, 6, -3, 6, 4, 9, and 1, 10. Okay, so just remember, each one of these is an XY pair. So if I look at 2, 6, that means if X is 2, the Y value is 6. Okay, so that's what each of these guys means. Okay, all right, I am going to build an arrow diagram because it's very visual, like I said. Okay, so we make a column for the X values and a column for the Y values. And to make it very readable, I'm going to start with the X values. you want to put them in ascending order. Put them from the smallest to the biggest. So if I look at my x values 2, -3, 4, and 1, the smallest one is -3, and then 1, and then 2, and then 4. Okay, this makes it more readable if you order them. Okay, I'm going to do the same thing for the y values. I see 6, 9, and 10. Okay, so 6, 9, and 10. Okay, they're in ascending order. And now I'm going to draw arrows. Okay, so basically, if x is 2, the y value is going to be 6. Okay, so I'm going to draw like that. And then the second ordered pair tells me if x is -3, the y value is 6. And then if x is 4, the y value is 9. And then lastly, if the x value is 1, the output is 10. Okay, so there's your arrow diagram. Okay, you can quickly scan this and see that this does represent a function. Every input does have a single output, but now we're thinking in terms of one-to-one. Is this a one-to-one function? Okay, well, remember what I told you. To be one-to-one, there can be no sharing. Okay, so here there is definitely a problem. Okay, if you look at the x values -3 and 2, they're both mapped to 6. Okay, so these two x values are sharing the same y value. Okay, so this prevents that. This characteristic prevents this function from being one-to-one. Okay, so I'm going to put here, this is not a one-to-one function, and I'm going to put a reason why. Because x equals -3 and x equals 2 share the same output, which is y equals 6. Okay, there cannot be any sharing whatsoever. Okay, let's take a look at part B. Okay, so now we have a new set of ordered pairs: 1, 2, 2, 8, 3, 18, 432, and 550. Okay, again, I'm going to draw out an arrow diagram. You don't have to. I just do this for readability. Again, I'm going to order my x values. I'm going to put them in ascending order. So we've got 1, 2, 3, 4, and 5. Okay, and then I'm going to do the same for the y values. We've got 2, 8, 18, 32, and 50. Okay, and then I'll draw my arrows. Okay, so 1 maps to 2, 2 maps to 8, 3 to 18. If x is 4, the y value is 32, and if the input is 5, the output is 50. Okay, so we can clearly see that this is definitely a function. Every input has a single output, and really clearly from this visual, you can see that there's no sharing between the x and y values. Every x value maps to exactly one y value, okay? A unique y value, okay? Like 1 maps to 2 and to nothing else, okay? Vice versa, 2 maps to 1 and nothing else, okay? There's no sharing among the x's and the y's, okay? Every x has a unique y, every y has a unique x, okay? So this is a one-to-one function. Okay, because there is no sharing. Okay, all right, so that is the whole idea of a one-to-one function. Okay, there can be no sharing.